Here are the notes for finding specific terms of the binomial expansion. So rather than doing every single coefficient and then every single a value, every single b value, we can just jump right to the fifth term. If you think about it, your fifth term, so like if this is Pascal's triangle, 1, 3, 3, 1, 1, 4, 6, 4, 1. This first one here, right, so we'll look at this row, even though I know that's not our n. Remember, these are my n's, okay? This would be when n equals 4, right? So that means this first guy would be 4C0, 4C1, 4C2, 4C3, 4C4, right? So term 1 is going to be your R value here, and NCR is going to be 1 less. Term 2, your R value is 1. Term 3, your R value is 2. Term 4, your R value is 3. So notice that? R is always 1 less than the term you want. Okay? So, if we look at this example, if they want the fifth term, that means R is equal to 4. And this is n equal to 9. So, rather than listing out all of my terms and trying to extend the Pascal's triangle or using my calculator to get the coefficients, I'm just going to write this in combination notation. So, NCR is going to be 9C4. Okay? A is still x. And remember, we said A goes down. Okay, so it starts at n as the exponent and goes down. So if I'm looking for my fifth term, you can count it out. It's going to start at x to the 9th is term 1, x to the 8th is term 2, x to the 7th is term 3, x to the 6th is term 4, x to the 5th is term 5. So this would have an exponent of 5. Your b is y. And remember, we said b goes up. So it starts at 0, oops, and it's going to go up from there. So y to the 0 is term 1, and then to the 1, and then 2, 3, 4, or 0, 1, 2, 3, 4. So then y is to the 4th. Okay? The trick here that we said in class is this r is going to be the same as the exponent for b. Okay? The exponent of a is going to be n minus r. So that's kind of something that you can always remember. All right, so let's see. N, I'll write it up here for you. This is going to be a, and this is going to be to the n minus r, versus b, it's going to just be to the r. Okay? So, good things to remember. All right, we are ready to simplify. So, evaluate this then. In your calculator, you need to actually plug in what is 9C4. So, you do 9, then go to math, probability, NCR. You get 126. This is still x to the 5th, and this is still y to the 4th. Okay, so then we've got that one. All right, we'll move on and do maybe this one, number 4. So they want the 4th term, and again, it looks like this is a 9. So if they want the 4th term, that means my r is equal to 1 less, which is 3. This exponent is 9, so n is equal to 9. So if I want to write it in combination notation, that's 9c3. My a is 2x. Remember, that exponent is n minus r, so 9 minus 3, 6. And then you've got negative 3y is your b. And that exponent is just whatever r is. Okay? In the next step, I'm going to evaluate each of these things. So 9c3 in your calculator gives you 84. 2x all raised to the 6th power, so that means 2 to the 6th power, which is 64, and then x to the 6th power, which is just x to the 6th power. Then you've got negative 3y all raised to the 3rd power, so negative 3 to the 3rd power is negative 27. Y to the 3rd power is just y cubed. We need to then multiply these 3 terms together. So multiply your numbers, and then if you had common bases, you would add your exponents. So 84 times 64 times negative 27 is this huge number. 145,152. I still have x to the 6th and y to the 3rd, which didn't simplify at all, right? Okay, so another example of finding just a specific term. In the next example here, they want us to write the first 3 terms. Okay, so in the warm-up and notes last class, you were expanding it for the whole thing. So we went through and put all of my coefficients of a, just all my whole numbers, and then a, and then all of its exponents, and then b, and all of its exponents. Here, I would probably just write it as combinations like we were doing. Okay, so if you think back to this Pascal's triangle here, my first term, remember, is NC0, NC1, NC2. That would be your first 3 terms, depending on whatever n is, right? So in this case, what is n? N, I think it's 7, it looks like. Okay, so the first one would be 7C0, 7C1, and remember we always have these plus signs, 7C2. All right, then you've got your a value. So in this case, it's x. All right, x, remember, a starts at whatever your exponent is, 7, and it goes down by 1. Then you've got your b value, which in this case is y. And it starts at 0, and it goes up by 1. Now, the other rule still applies. The exponent of a is still, so like 7c0, it's still 7 minus 0, which is 7. And the exponent of, y is still matches, right? See how these all match? All right, then the next thing to do would be to simplify. So y to the 0 is just 1. 7c0 is just 1, so I'm just left with x to the 7th. 7c1 is 7, x to the 6th, and y to the 1. You can put it or not. And then 7c2 is 21. Then you've got x to the 5th and y squared. I'm going to put, dots to say it keeps going, but they just wanted the first 3 terms. So 1, 2, 3. I'm done. Okay, we can do another example. Oh, I'm sorry, I didn't know it was recording. So in this one, write the first 3 terms again. and this is an exponent of 8, it looks like. So it's going to be 8c0. I'm going to do this all in one step. A is 4. The exponent of 4 is 8 minus 0, so that's 8. My b is negative y, and the exponent of b is whatever r is, so that's 0. So there's your first term. Your second term, 8c1, a is 4. To get the exponent, you have to do n minus r, so 8 minus 1 is 7. And then your b is negative y, and the exponent of y is whatever r is, so 1. Then you've got 8c2. Your a is 4. The exponent is n minus r, so 8 minus 2 is 6. And b is negative y. The exponent of b is 2. Now we're ready to simplify. So 8c0 is 1. 4 to the 8th power is 6, 5, 5, 3, 6. And then negative y to the 0 is just 1. 8c1 is 8. 4 to the 7th power is 16, 3, 8, 4. And I still have negative y because it's just raised to the 1. 8c2 is 28. And then, whoops. And then 4 to the 6th power is 40, 96. And then negative 1y squared becomes positive y squared. Okay, next step would be just to multiply everything together. So this just stays 6, 5, 5, 3, 6. 8 times this times negative 1 becomes negative 131,072. And I still have a y there. And then 28 times 40, 96. 114,688 y squared. And we would be done with that one. So practice with the binomial theorem, and we'll do more next class.